Interstellar objects such as 3I/Atlas represent an extraordinary and rare opportunity for humanity, a kind of cosmic gift that arrives unexpectedly after traveling immense distances across the galaxy. These objects take millions, even billions, of years to drift from their star systems of origin into the inner regions of our solar system, carrying with them unaltered samples of material that formed around foreign suns long before human beings even existed. For scientists on Earth, the chance to observe such an object up close is comparable to receiving a time capsule from a distant civilization or a message in a bottle from another part of the Milky Way. Our spacecraft would require unimaginable amounts of time to travel to these distant star-forming regions and explore them directly. Yet interstellar objects cross our path naturally and deliver the same primordial materials right to our doorstep. That alone opens a new frontier for research that can dramatically expand our understanding of how planets, stars, and possibly even life itself emerge across the galaxy. Rather than waiting for technology that may never arrive or missions that could exceed human lifespans, we are given the rare privilege of learning from these travelers in real time. The scientific implications of such encounters are vast. Interstellar objects like 3I/Atlas provide clues about the chemical composition, structural formation, and environmental conditions of planetary systems beyond our own. By analyzing their surfaces, tails, mineral content, and potential organic compounds, researchers can begin piecing together a more complete map of the Milky Way's diversity. These objects may carry exotic isotopes, unusual molecular combinations, or complex organic compounds that do not naturally occur in our solar system. Each discovery could reshape existing theories about the formation of life, the distribution of water, or the prevalence of habitable environments near other stars. Additionally, they allow us to compare the materials in our solar system with those from elsewhere, identifying universal patterns and unique anomalies. This comparison is essential for astrobiology, as it may reveal whether the seeds of life, amino acids, nucleobases, or even more complex precursors, are widespread throughout the galaxy or rare and isolated to specific stellar nurseries. Beyond the strictly scientific interests, interstellar visitors also raise profound questions about technology, intelligence, and the possibility of extraterrestrial civilizations. The simple fact that natural objects can drift so far and enter our solar system suggests the possibility that artificial objects might do the same. Humanity sends probes outward, some of which will eventually leave the solar system and wander among the stars for eons. If another civilization ever did something similar, one of their ancient probes could drift near Earth without us immediately realizing its artificial origin. It is for this reason that some researchers, political figures, and commentators have raised concerns about whether humanity is prepared to identify, analyze, or respond to an interstellar technological artifact. Representative Anna Paulina Luna, for example, has expressed interest in discussing potential protocols for dealing with probes, should any be discovered. The truth is that, despite decades of science fiction imagining such a scenario, humanity has no formal plan for handling the discovery of a functioning alien device near Earth. Unlike detecting a radio transmission from a distant star, which could be studied slowly and safely from afar, discovering a technological object physically present in our solar system would demand immediate action. Such a visitor could approach Earth, alter its trajectory, or even remain in orbit, and its intentions, whether benign or harmful, would be unknown. Currently, the U.S. government, NASA, and international space agencies have policies for monitoring natural threats, such as asteroids. In 2005, Congress mandated that NASA identify at least 90% of near-Earth objects larger than 140 meters, roughly the size of a football field. These objects represent natural dangers that could cause regional or global devastation if they were to collide with our planet. However, these planning frameworks do not extend to potentially artificial objects. Alien technology, if it exists, would be far less predictable than rocks. It could change direction, emit signals, release smaller devices, or perform actions we cannot yet imagine. For this reason, Some scientists have urged the development of international guidelines for identifying, studying, and responding to interstellar objects of uncertain origin. In fact, a white paper was recently submitted to the United Nations that encourages the formation of an international committee responsible for addressing the threats or opportunities posed by interstellar visitors. This proposal acknowledges that the discovery of alien technology would be a global issue, not the responsibility of any single nation. It would require cooperation among space agencies, scientists, governments, and defense organizations. Humanity must consider the possibility that we may someday detect such a device, and failing to prepare would risk confusion, miscommunication, and unsafe responses. At the moment, however, no government or scientific body has such protocols in place. This absence of preparation highlights a gap in our understanding and readiness, especially in an era when interstellar objects appear to be passing through our solar system more frequently than once believed. As for whether NASA or other government agencies know more about 3I/Atlas than they publicly acknowledge, the answer is almost certainly no. Delays in releasing data or reports often have mundane explanations, such as bureaucratic constraints or funding interruptions. In the recent case, NASA's delays stemmed from the U.S. government shutdown, which temporarily disrupted communication and data flow across multiple departments. While some individuals may speculate that such delays indicate hidden knowledge or secret discoveries, these assumptions overlook the reality that large government organizations often move slowly due to administrative bottlenecks. It is far more likely that the slowdown reflects terrestrial inefficiency rather than extraterrestrial intrigue. Scientists tend to share findings eagerly, especially when they involve an interstellar object, because discoveries of this nature strengthen careers, advance knowledge, and attract global attention. Hiding such discoveries would not serve the interests of research institutions or the scientific community. Another question that often arises is whether recent discoveries on Mars, such as hints of ancient organic molecules or geological features that may have been shaped by microbial life, could in any way be connected to interstellar objects like 3I/Atlas. The speculation is imaginative but highly unlikely. Mars has its own independent geological history shaped by volcanic activity, atmospheric changes, water flow, and chemical evolution. Any ancient life that may have existed on Mars would have developed in response to conditions specific to that planet. While interstellar objects occasionally impact planets, including Mars, there is no evidence that such interactions seeded entire civilizations or biologically influenced planetary development on a large scale. Interstellar objects might carry organic material, but the idea that a fully developed ancient Martian civilization could be connected to 3I/Atlas stretches beyond what current scientific understanding can support. Nonetheless, considering such possibilities encourages humanity to remain curious and open-minded. The universe is vast, and our knowledge is still in its infancy. Encounters with interstellar objects like 3I/Atlas are reminders that we are part of a much larger cosmic environment filled with mysteries that challenge our assumptions. These objects inspire scientific, philosophical, and even political questions that push humanity toward greater preparedness, broader vision, and deeper curiosity about the unknown. Whether studying their mineral structures, analyzing their trajectories, or contemplating the implications of their origins, each interstellar visitor urges us to look beyond the boundaries of our solar system and expand the scope of human understanding. In that sense, 3I/Atlas is more than just an astronomical event. It is a symbol of the untapped knowledge that awaits us among the stars and an invitation to advance our scientific readiness for whatever the universe may send our way.